Hello, this is Nas Babar from NB Network Lessons. Hope you all are doing well. Today I'm here with another lecture on traceroute. If you've been following me on my last lecture, I went over ICMP, which is the ping. Now, today I'm going to go over traceroute, which is really an important tool used in the networking world. Network engineers use that. It's widely used by desktop also to find out path from point A to point B. You want to know what's in between the path, how many hops are in between the path. So that's what traceroute is. I'm going to give you an example, and this might make a little more sense to you. I live in North Texas, North Dallas. My office is in South Dallas. So I have two ways to get to my office. One is I can take North Texas Tollway from north to south all the way. And the second one is I can take Sam Rayburn, which is Highway 121, and then I can take I-35 south and reach my destination. So I have two paths, and in the morning, sometime I get up and I look at my GPS and say which path is congested and which path is less congested, and obviously I take the path which is less congested. So having that in your mind, I'm going to go ahead and dive into traceroute. Now, one thing I just want to caution, if my video exceeds more than 10 minutes, there will be two parts, okay? So keep that in mind. So without further ado, let's go ahead and dive into traceroute. Traceroute is basically, why do we use traceroute? We use the traceroute to see the path of the network it takes. How many hops does it take? Time it takes to reach the destination. So that's what traceroute tells you. So now we're going to get into nitty-gritty of the traceroute. Let's say you have this network right here. You have R1 connected, router 1, which is a Cisco router, PC1, which is just a PC or a laptop connected to the same network. I have two paths to get to my office or my destination, which is PC2, and the IP address of that is 50.50.50.50. I can take this path, or I can take this path right here, the one in red or the one on green. Obviously, when you look at it and say, oh, looks like the green path might be quicker because it has less hops, and that's what dynamic routing does. Dynamic routing will basically consider, how many hops, is the path congested or not congested, latency, and so forth. Well, for the sake of discussion, let's say, this path is broken, right? Something's wrong with this path, and we're, basically our packets are taking this path, the one in the red. So we will dive into that. So basically same thing, you go to the command prompt if I'm assuming you're using Windows. So on the bottom left, search, type in CMD, which is short for command. It'll pop up a black screen, which is which has the command prompt. So I'm assuming we're logged in and we're into the black screen, and we type the trace RT 50.50.50.50 from the command prompt. I want to find out, how many hops, how much time does it take to get to my destination. This is my source right here. So when I type this in, trace RT 50.50.50. Now, one quick clarification. The word is traceroute. If you're doing a traceroute from a router, you will type the whole word, traceroute, and then IP of the destination. But in Windows, you type in trace, TRACERT. Why? Because back in the days, disk operating systems only allowed 8 characters. And this still, the case is same. Disk operating systems still allow only 8 characters. So that's why we had to shrink traceroute to traceRT. Anyways, so I executed this command. First hop is my packet leaves PC1, ICMP leaves PC1, hits R2 right here. Let me just erase that real quick. When PC1 sends ICMP to R2, it sends a time to live of 1. That means, hey, you're leaving, you can live only 1 hop. Okay, so keep that in mind. So I'm sending my first ICMP time to live set in the packet is 1. Okay, so when the packet hits R2, what R2 is going to do is it's going to decrement it by 1. So it receives the TTL of 1, it decrements it by 1, so you have 0. What does 0 means in ICMP? 1. So it receives the TTL of 1, it decrements it by 1, so you have 0. What does 0 means in ICMP? Code 0 means that, hey, in the transit, the TTL, time to live, has exceeded. I'm going to send it back to PC1. And that's exactly what's happening in this case. This router, to get to this router, it took me 8 milliseconds. It sends 3 ICMP, okay? Because we want to get the average. We want to hit it 3 times and get the average. So it hit 3 times, 8 milliseconds, first try, 9 milliseconds, second try, 9 milliseconds, third try, just decent. So that's my first hop. Now, getting to the second, all right, once it's 0, TTL time exceeded, it can only live for 1 hop, it's sent back to the PC1. Then PC1 sends it again with a TTL of 2, right? So now router 3 receives the packet, TTL 2, it decrements first, R2 receives it, TTL 2, it decrements 2 minus 1 is equal to 1. When this R3 receives it, it has TTL of 1, 1 minus 1 equal to 0, sent back to originator. Okay, so you see the mechanism over here. I'm sending first ICMP with TTL 1, hits the R2, it decrements it by 1, becomes 0, comes back. Second packet, ICMP has sent it with TTL 2, hits the first router says TTL 2, subtracts 1, sends it to R3. R3 receives the TTL 1, subtracts 1, and it becomes 0, sent back to PC1. So on the second one, 3 tries, 20 millisecond, 20 millisecond, 20 millisecond, and R3 is the hop. This is basically resolving the name through DNS. We move on. PC1 sends a packet with TTL of 3 now. First router decrements it and it becomes 2. Second router decrements it and it becomes 1. It receives R4. R4 decrements it by 1. So 1 minus 1 becomes 0. Boom. Coming back to PC1. If you're looking right here, this is what we have right here. Number 3, 25 millisecond, 26 millisecond, 20 milliseconds, 3 tries, 3 ICMP. And then basically R4 is sending back type 11 code 0, which is basically, hey, time to live has exceeded, and I'm sending it back to you. Now PC1 says, okay, let me send it with TTL 4. So it sends it with TTL 4, R2 is going to take it, decrement it by 1, so it becomes 3. R3 sees it, decrements it by 1, TTL becomes 2. All right, R4 sees it, decrements it by 1, it becomes 1. And then when the ICMP reaches R5, at that point your TTL is 0, but you've reached your destination. So then you get a message back saying, hey, the trace is complete, and this is the final one. It took 70 milliseconds. We tried 3 times, and every try we got 70 milliseconds to get to our destination, 50.50.50.50. So that's what traceroute is. One thing, if you do a traceroute from a router, and this is an exam question, by the way, so please pay attention. When you do a trace route from R1, you type the whole word trace route, right? And it uses UDP. Initial packets are sent using UDP, which is the layer 4 protocol, but the TTL mechanism is same. All right, it's just that the router uses UDP. I'm gonna put it down right here. When you send initial packet from R1, it uses UDP, any Cisco router which has iOS. when you use a PC or laptop, initial packets are sent in form of ICMP, which is another protocol, ping protocol, as you all know. All right. However, the return uses the same mechanism. In this case also, case of router also, you get the ICMP exceeded message using ICMP, and the same thing on the PC. So hopefully this makes sense to you. Take a look at it, maybe watch the video 2 or 3 times. If you have any questions, send me a message. And if you want me to discuss something else, your topic of choice in the area of network, which is my expertise, send me the message and I'll be more than happy to go over that. Thank you so much for watching. If you like the contents, go ahead and give me a like. Till then, till next time, see you. Bye.